Hi everyone, this is Janine aka Janine the Tutor. As you know, now is a very difficult time for each one of us, whether you're in middle school, high school, or university. Many students and families are deeply affected by the recent school closure. And as a part of OneClass, we are very fortunate that we are able to adapt quickly, and that's why we want to extend our helping hand to you students for you to stay on top of your studies. That's why we are running free and daily classes for math and chemistry from grades 11 to first year college and university. In addition, we are also giving away 100,000 hours of free private tutoring. So if you're interested, make sure to scroll down below and book your time slot. For today's class, I will be going over the popular Q&A questions that we've received from students, which have been extremely popular over the years. So let's get to it. Yeah, before I even start, I just wanted to make sure you can hear me coming through and you can see my screen. So you should be seeing live stream 1. So this is the first Q&A math session that I'm doing and the date. Okay, great. So, and also, before I get started, as I always tell my students, right, if you know anyone who might benefit from this, please ask them, right? Call or text them, ask them to join. I think learning as a group just makes it more fun. So yeah, please do that. Okay, great. So for number 45, right? So I'm going over the most popular question until we get to the least popular question in that sense. Okay, great. So here's the first question. It says, how do you find the exact value of cosine 3 pi over 4? Okay, so if you're in pre-calculus right now or advanced functions or you're in grade 12, so we've learned back then that if you have, let's say, cosine, right, typically it would be in the form of an angle, right? So now we're dealing with radians, right? Because we know that radians is also a unit of measurement for angles, right? So because this is 3 pi over 4, right, let's start off by writing or drawing our quadrants. Okay, so first of all, when we have cosine 3 pi over 4, how do we know what 3 pi over 4 is, right? So here's the thing. Because you're still unfamiliar, right, which is totally fine, right, because we're used to seeing degrees in terms of the measurement of the angle, right? Even me, I'm used to seeing degrees, right? When I learned radians, I was like, okay, what is this, right? So remember how pi is actually 180 degrees, right? So that's what we're going to do today. So we're taking 3 times 180 divided by 4. Because some students, it's still I guess boggles them in terms of just looking at the angle and they're not really sure where 3 pi over 4 is if they're reading this in radians. So what I tell my students, right, you know that pi is equal to 180 degrees, right? So all you have to do is convert this into degrees and then kind of map that into your head and actually visualize that. Okay, so I know that 3 times 180 divided by 4, that's equal to 135 degrees, right? So I know that 3 pi over 4 is in fact 135 degrees. So now I know that this is 135 degrees. I actually know where that is in my quadrant. So this is actually found in quadrant 2, right? So that's what 3 pi over 4, or that's how 3 pi over 4 looks like, because you're starting from this, right? This is 0 degrees. Basically, you're opening up. Does that make sense? So this is 3 pi over 4, which is 135 degrees. Okay, so now that you know that, right, if you remember, we actually have related acute angles, right? So what are related acute angles? It's basically your other angle, right? Because you know that this opens up starting from here to here, right? First of all, this is quadrant 1 and this is quadrant 2. So there should be another angle, right? Because remember, you have your x-axis here. So in your x-axis, you do have a straight angle. So in that case, this would be another angle, right? Starting from this quadrant, right? So if you're going clockwise this time, right? So you're starting from this 0 degrees, but now this is going to be a negative value, right? Because you're going against where you typically have that positive angle. Does that make sense? So you're going the opposite way, right? As opposed to going counterclockwise. So now this would be a negative value. And if you recall, right, so all you have to do is, have pi, right, minus 3 pi over 4. So let's do that. And make sure your calculator is actually in radians, because if it's in degrees, you're pretty much um, done for. Because I know I've had students in the past who come to me and they're like, oh, so my calculators is in degrees, right? I'm taking a test where everything is in radians, and they had a calculator which is in degrees, so you can't really find the exact same value. So make sure check your calculator first. So yeah, so as I mentioned, you know that this is a straight angle, this is pi, right? So all you do is you take pi minus 3 pi over 4. So you're going to get pi over 4, right? So you know that this is pi over 4. So this pi over 4, I know for a fact that this is 2 pi minus 3 pi over 4. So I know that the related acute angle would be pi over 4, right? And in fact, that's going to be negative, right? So this is my related acute angle. And as you all know, I like to do 180 divided by 4, right? So this is 45 degrees, right? So I know that this is 45 degrees. And because we have special triangles, right? So what are special triangles? If you remember your 45, 45, 90 triangles, right? So we know that this is 45 degrees, so this must be pi over 4 as well, which is 45 degrees. And then you have your right angle over here. So now, right, because if you go back to the question, okay, let's go back to the question. So on the question, it says you need to find the exact value of cosine 3 pi over 4, right? So we're going to use the special angle and see what the exact value of cosine 3 pi over 4 is, right? So now, because we know that the related acute angle is pi over 4, we have that negative sign and we have cosine pi over 4, right? Let me try to move this down so you guys can see that. Okay, great. Can you guys see that? So I'm saying that cosine 3 pi over 4 is the exact same value as the negative of cosine pi over 4, because pi over 4 is your related acute angle, right? And because you're starting from this opposite side of your x-axis, right? That means this is going to be a negative value. Okay, so now that we have that, right? And if you recall our special angle 45, 45, 90, this is basically 1, right? And then your right angle opposite of that, which is your hypotenuse, this is square root of 2. And then on the other hand, because this is pi over 4 and this is also pi over 4, which is both 45 degrees, therefore you can say that this is going to be 1 and this is also equal to 1. Okay, great. So we know what the values are. So in this case, we know that this is cosine pi over 4, right? So what is cosine again? If you remember SOHCAHTOA, it's adjacent over hypotenuse, right? I should write that down. Okay, SOHCAHTOA. So this is how I remember, if I'm talking about cosine, I know to look for the adjacent side and the hypotenuse. So adjacent of pi over 4 would be this, right? So that means it's going to be negative, right? Because of that negative sign over there, and you have 1, and hypotenuse, so adjacent over hypotenuse, so hypotenuse would be square root of 2. So that's why you have a square root of 2 here, and because we want to rationalize, we can't have radicals in our denominator, therefore we need to multiply this to square root of 2, right? Because remember, in math you cannot have a radical in your denominator. Okay, great. So once we have that, right, we're going to get negative 1 times square root of 2, that would be negative square root of 2, and as a result, your denominator, that gets rid of your exponents, right? Square root of 2 times square root of 2 is going to be simply 2, right? So that's how we know that this is cosine 3 pi over 4 is actually equal to negative square root of 2. And when you try to plug this into your calculator, right, like right now, cosine 3 pi over 4, when you punch that in, this is equivalent to this. Does that make sense? So in order for you to find the exact value of whatever angle you're looking for, you need to look at your related angles if you don't have a calculator in front of you. Okay, great. But again, depending on your teacher, right? If you're taking advanced functions or pre-calculus, typically you would have a calculator but at that point. So this is not even necessary. But this is just a way to visualize if you're doing this manually. Okay, hopefully that was clear. I didn't want to overcomplicate things because you do have your calculator, but that's how you're going to solve this question. Okay, let's see what they said. By the way, just so you know, I'm currently at oneclass.com/homework-help, and these are all questions in the math section. Okay. Yeah, so as you can see, they've said that cosine 3 pi over 4, can you guys see this? And you have negative cosine pi over 4, which is exactly what we said. And they're looking at the 45, 45, 90-degree triangle. And you have the sides of 1, 1, and square root of 2. Personally, I think that the question, what they've said, it's right. But I think because it's trig, I would really appreciate if we do have a right angle to actually visualize that, and also the angles, like 3 pi over 4. I know they specifically mentioned that it's in the second quadrant, but I think I would really appreciate, even as a student, for example, if I'm learning this, right, I want to see quadrant 1, quadrant 2, 3, and 4, and this 3 pi over 4 plotted. Does that make sense? So yeah, to make this better, I would say this is right, but I'm looking for something that's very visual, which I've talked about, hopefully, and you understand it. Okay, let's move on to the second question. But so far, the answer was right. I guess it's just more the way they presented the answer is something to improve on. Okay, great. So here it says how many quarts are in a gallon. Okay, so first of all, in math, right, we do have quarts, pint, gallon, so on and so forth, right? So these are what you call the English system of measurements, right? Because typically when you're in science, when you're in math, you would have to use the SI units or the system of international units. Okay, great. But yeah, it's abbreviated as SI units, right? So anytime you have quarts and you're referring to gallons, right, you have to remember that every gallon you have 4 quarts, and that's it. You don't really need to prove this because this is just the way they tell you. For every 1 gallon, that's 4 quarts. That's something that you need to know. There's no way that you can prove this, right? So I think just as a straightforward, I guess, explanation, I'm just looking for 1 gallon is equal to 4 quarts, and that's it. Yeah, because there's a huge paragraph here, and I mean, I appreciate that they're actually trying to explain that gallon is a measuring unit for liquid, and it's widely used in the United States, but I think because we want information that's really quick, right? You can just say that 1 gallon is 4 quarts, and this is based on the English system of measurements, and that's it. That's the only thing that I'm looking for. But yeah, this is right. Okay, next. Okay, this is an interesting question because I think even though you're in a higher level, right, some students, they actually don't know how to express repeating decimal numbers into fraction, which is very interesting. So that's what we're going to do today. Okay, so it says, what is 0.3 repeating as a fraction in simplest form? Okay, so this, they've actually showed you a step-by-step solution, which I think is brilliant because I really appreciate when someone walks me through a step-by-step solution, right? In a way that I can understand. So, okay, so let's see what they did. So they're saying that you have this number, which is x. So we're taking this 0.3, and just as a correction, there should be a line, a bar line over here, which says 0.3. So 3 is the repeating number. So that should be there, which is this. Does that make sense? So I guess that's the only correction that I have here. Make sure you have that bar symbol on top because otherwise when you read it as 0.3, that's not a repeating decimal number. Okay, so they're saying let the number x be 0.3 and you have x, and then basically they're multiplying 10x, which is equal to 3.3. So the whole point of multiplying this by 10, it's because you want to make sure that if you have a repeating number over here, so say for example you have 0.3 and 3 is repeating, you want to be able to move your decimal point to the number that is repeating. So in order for you to do that, you can only move this decimal point once, and that's to the right. Can you guys see this? Maybe I can just illustrate that. Okay, so this is 0.3, right? So the way they solved it, right, is because, again, this is what I was referring to. Make sure you have that bar symbol because you're saying that 3 is repeating. So as I was saying, this over here, right, the reason why they're saying, so they're saying this is x. Let's write that. Okay, so we have x, which is equal to 0.3, and that's repeating. And then they're multiplying the whole thing by 10, right? So 10x is equal to, so multiplying this by 10 would result to the movement of your decimal point to the right once, because you only have 10, and the fact that you're multiplying, that's why it's 10, and that's one decimal place value. So that would turn it into 3.3 because we know that this 3 is repeating, right? So once you have that, the purpose of having this is because you want to eliminate your repeating number as much as you can, right? So once you have that, all you do is you take 10x, right? And because you know that x is 0.3, you're going to subtract that with x over here. So this is 3.3. And as a result, because you have 3.3 here, you want to get rid of this decimal number, which is repeating. That's why this is minus 0.3. Can you guys see the resemblance? Basically, I wanted to get rid of 3 over here. So in order for me to get rid of that, I would have to subtract that with 0.3. And this is repeating, right? So as a result, I get 9x, right? And this would be, so 3.3. So you're going to treat this as 3.3 minus 0.3. That would just be 3, right? So it's a whole number now. Now, you would have to divide this with 9, right? So I would have x, which is equal to 1 over 3. Therefore, when you try to type this into your calculator, you would have 1 divided by 3, and you would get 0.3, which is repeating, and it's right. So, yeah, and that's what I did, right? But I think I would appreciate if there was more explanation on this point. I mean, it's not me like trying to nitpick, but I think the way the majority of my students learn is if someone is there to be able to explain, okay, why am I multiplying this by 10? I think that would even makes more sense. Yeah, but the way they've presented the solution is right. So you have 10x, and basically you have equal to 3.3, and this is repeating. And then on the other hand, you're going to subtract that with x, right? Why are you subtracting that with x and 0.3? Because you want to get rid of that repeating number, which is this 3 over here. Can you guys see this? And as a result, you're going to get 3, which is a whole number, and then you're going to divide that with 9, so you get 1 over 3, which is exactly what I have, and it's right. Okay, so 129. Okay, as you can see, they don't really have the question here, but just by reading the solution, I am able to tell what they're asking for. Okay, so they're asking for the decimal number 0.83 is equivalent to which fraction, right? So because there's no question here, right? The question that they're looking for, right? I mean, just by reading the solutions, you can actually tell. They're looking for the fraction when your decimal is 0.83, and the one that's repeating is 3, not 8. Does that make sense? So how do you express 0.83 with 3 being repeating as a fraction? That's the question. So yeah, the reason I know the question isn't there, but the reason why I wanted to bring that up is because it's related to the first question we did, right? And I think repeating questions with the same concept just gives you, I guess, it's just better for you to process and think about it in a different way. And I mean, it's not the exact same question, right? So we can just go over it. Okay, so we have to have 0.83, and 3 is repeating, right? So now if you go back to this question, right, we said only one number was repeating, right? And it's just the 10th place value. So just go back to middle school. What is this place value? This is TENTH, right? This is the 10th place value, right? And over here, this is actually the 100. So with the TH, remember? So the TH would represent any number that is after the decimal point, so that's your place value. And if you're looking at 0 0.3, the one that's repeating is actually the 10th place value over here, which is exactly after the decimal point. So now that it's 100, right, that means instead of having 10, right, you need to move this twice because your decimal number that is repeating is on the 100th place value. Therefore, you're going to move this, right, 2 times, right? That's why it's 100. So let's do that. Okay, so this is 100x, right? Does that make sense? So now that this is 100x, therefore this is going to be 83.3. So so the goal here of multiplying 10x and 100x is to basically bypass your decimal number that is repeating, right? That's why you have 0.83, and you want to move 2 places to the right. That's why it's twice, because there's 2 zeros, and to the right because you're multiplying. That's why it's 83.3 now, right? So now you're going to think, okay, so how do I get rid of this 3 over here, right? Does that make sense? So for me to get rid of this 3 over here, I would just have to move the decimal point to the right once, because in that way I would get 8.3, right? So when I subtract this from 8.3, it gets rid of this and this. So I get a whole number. Does that make sense? So yeah, this type of question, you just have to look at the number and kind of see how it would get rid of the decimal number that's repeating. Okay, great. So that would be 10x, right? So we have 10x because when you move this here, you would get 8.3, and that's repeating at 3, right? So when I write this up, I would have 100x minus 10x, which is equal to 83.3 repeating minus 8.3 repeating, right? So if I take this number and this number, I subtract them together. Let's see. You would get 83.3 minus 8.3. That would give you 75, right? So this is actually 90x, and this is equal to 75. Dividing both sides with 90. So 75 divided by 90. This is x is equal to 5 over 6, right? Yeah, so x is equal to 5 over 6. So now that you know that x is equal to 5 over 6, right, that means the equivalent of 0.83 repeating is actually 5 over 6. And when you actually do get the chance, right, if you divided 5 with 6, you're going to get 0.8333, and so on and so forth, right? So this is your answer. Okay, let's go back to the question and see what they wrote. Okay, so they took 10x and you have 8.3, which is right. Yeah, which is 5 over 6. Yeah. So exactly the same answer and solution base of mine. But again, I would appreciate if they would explain and elaborate more as to why we're using 10x now as opposed to just x, right? And again, we wanted to get rid of that repeating number at the end, right? So we can express that into a fraction. Okay, so we've done that so far. Okay, let's move on to this question. Okay, here it says, okay, now we do have a question. So it says, how many cubic units is a box that is 3 units high, 3 units wide, and 2 units deep? Okay, so first of all, just ask yourself, what exactly is this question looking for, right? So because they're looking for cubic units, right? What does cubic units mean, right? So how do we even know what they're asking for? Is it volume? Is it area, right? Based off of the units that they're giving, right? So because it's what did they say again? Cubic units. Yeah, because they're saying it's cubic units that they're looking for, so anything that is in black is given. So they're saying units, right? And that's cube of that, right? Therefore, it has to come to you, or it has to be your own intuition that they're actually looking for the volume, right? Cubic units mean that's the unit for volume, right? If it's not specified, because this could be centimeters, it could be any unit. When it's cubed, that means you're looking for the volume, right? So if you're looking for the volume, they're saying it's a box, right? So a box would be a cube. I mean, not the cube over here, right? Cube just means it's raised to the power of 3, but it's a box, right? So we're assuming that it's a cube shaped. Okay, there. And okay, so it's a cube, and basically the question is saying we have 3 units high, 3 units wide, and 2 units deep. So that's the height. This is the width, right? 2 units deep is basically the length. Or, yeah, this part. 2 units deep. Okay, so as you can see, the 3 units high is basically this, right? So this is 3. 3 units wide would be this. And then 2 units deep would be this too, right? So if you remember, in order for you to find the volume of a cube, right, all you have to do is multiply length, width times the height, or side times the height, right? So in that case, all you have to do is multiply 3 times 3 times 2, right? That would be 3 times 3, so that's 9 times 2, that's 18. So this is 18 cubic units. Okay, great. That's it. I don't think that question was too bad, so yeah, 18 cubic units. Okay, so this question, it's asking how many edges does a cube have, right? And yeah, amazing. So they actually gave us a figure which we can use, right? So as you can see, if we have a cube, right? I think probably everyone knows what a cube is and how it looks like by now. So if you have a cube, right? And if not, this is how a cube looks like, right? So if you have a cube, right? First of all, you have your vertex. So vertex is where 2 lines meet. Can you guys see this? This is basically what you call the corner of your cube. And then you have the face, which is it's a plane, right? That's what a face is. And then you have an edge, right? As you can see, this is an edge. So if you look at this cube over here, they're asking how many edges does a cube have. So basically all you have to do is draw a cube on a sheet of paper and then you count, right? So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? So that means there's 12 edges in a cube. Simple as that. I don't think there should be a formula to this. Because if you know how to draw a cube, I think you should be able to tell just by looking at the figure. Because remember, the whole point in math, right? I mean, the way I see math is if you're able to remember the information without even trying to memorize as much as you can. I mean, there are some formulas that you need to memorize, but you want to reduce the amount of information that you can memorize, but you want to be able at the same time to just look at the figure and tell what are the edges, what are the vertex or vertices, and what are the faces, right? I think that way it's easier for you to remember this information until you graduate. So just reduce the amount of memorization if you can. Because I mean, if you try to memorize this formula, right, it's only going to be with you, or you're only going to remember this at some point in your life, and then probably you're just gonna forget this. So yeah, that's just my opinion in terms of learning math. Okay, here. So it says, what is the first step when rewriting y is equal to 3x squared plus 9x minus 18 in the form of the vertex form, right? Hopefully by now you know what the vertex form is, which is y is equal to ax minus h squared plus k. And as you can see, this is what you call the standard form, right? Did I even mention that? Okay, they didn't. But you should know that this is the standard form, ax squared plus bx plus c, right? In this case, this is minus c, but you get the point, right? The standard form is basically this, and you have the vertex form. And you need to write this in terms of this, right? And they're only asking what's the first step, right? So that means you don't have to exactly solve the question, right? Because you just have to figure out what's the first step. So the first step is to actually complete the square, right? But in order for you to complete the square, you need to factor your negative 18. But let's do that. Okay, so the question is y is equal to 3x squared plus 9x minus 18. So this is your function, right? And remember what they were asking for. What's the first step so that you can actually have this y is equal to a times x minus h squared plus k. Or was it x plus h? It doesn't really matter, but it's in the vertex form. Okay. Okay, they use x minus h squared plus k. Right. So first thing you have to do is, because you know that there's a 3 here, you're going to factor the 3 out. So you're going to get x squared plus, so 9 divided by 3, that's going to be 3x. And then at the same time, you're going to have this negative 18 over here, right? So what you're trying to do is you're going to make sure that this is completely blank because you wanted to complete the square, right? I mean, that's how you're going to get to x minus h squared plus k, is because you want to complete the square from this, right? And if you think about it, you need to go back to this equation again and see whether these two are equal to one another. Because if you have this unequal to this, then your solution or your equation is going to be wrong, right? Okay, so if you try to multiply this back, so it would become 3x squared. So distribute 3x squared, and then you have plus 3 times 3x, that would give you 9x. So that's exactly the same equation compared to the first one, right? So it's the exact same thing, so that means you're on the right track. Okay, great. So that's the first step that you need to do, right? And let's see what they did. So yeah, I guess the first step is to factor and then you complete the square. So they said 3x squared plus 3x minus 18. Yes, this is the first step. So they're absolutely right. Okay, but anyways, since we're on the same topic, right, we wanted to know the vertex form, right? I know this is like the first step. So this is the first step. I should have wrote step 1. Okay, step 1. Yeah, so this is step 1, right? As you can see. But what about the second step, right? How do you arrive to this, right? I know there's a lot of students who's probably struggling on this, like completing the square, but honestly, it's the easiest thing that you can possibly imagine if you understand it, right? Okay, so once we've factored out the 3, all you have to do is go and look for your b. So how do I know this is b? Well, remember, this is in the standard form, so this is ax plus bx, or ax squared rather. This is plus bx, and this is minus c. So now you know that your b is going to be 3, right? So you're going to take b divided by 2, and you're going to square that, right? So you know that your b is 3. You divide that with 2, and then you square that. So that means this term, right, would be placed in here, right? Because now you're completing the square. Okay, so you have 3 over 2 and you square that. So that would be 9 over 4, right? So now you know that, okay, let's scroll down. Yeah, so now you know that this is 9 over 4. So when you write your equation, you're going to have the 3, which is still here. And then you have x squared plus 3x. And now this is going to be plus 9 over 4. Does that make sense? Because you're inserting a new number or a new term over here, right, which was not there to begin with, that means you need to also subtract that, right? Because you want to make sure that you don't add any of the terms, right, over here, because to begin with, you don't really have that term, right? Otherwise, your equation would be imbalanced. So once you've added the 9 over 4 and you still have the negative 18 over there, you're going to take 3 times 9 over 4. So 3 times 9 over 4, so that's equal to 27 over 4, right, when you multiply this and this. And the reason why I'm subtracting, it's because when you have this and this, it's a positive number. It's positive 27 over 4. So for it to become 0, right, you're going to have 27 over 4 minus 27 over 4, which is equal to 0. So that means it balances out the equation, right? Because you're not introducing terms. Does that make sense? In a way that you're having this negative 27 over 4. Okay, great. So we now have that, and then we're going to write this as 3. Okay, because we're completing the square, right? What's the rule when you're completing the square? That means you're going to take x, and because this is positive, therefore this must be positive. If this is negative, this has to be negative. And then you're going to take the square root of this, right? So the square root of this would be 3 over 2, and then you're going to square that because this is squared, right? From the vertex form. So you're going to square that, and then as a result, yeah, so you're going to square this. And then as a result, you're going to take negative 18 minus 27 over 4. So when you combine negative 18 minus 27 over 4, you're going to get negative 99 over 4, right? And your vertex form is actually this. And that's it. So that's how you're going to solve this question. But again, because they're only looking for step 1, right? It's just going to be this, which is exactly right. Okay, so here's the question. Which is bigger? Is it 63 centimeters or 6 meters? Okay, 63 centimeters. First of all, you can't really start comparing units that are different, right? Okay, was it 6 meters? Let's see. Yeah, 63 centimeters or 6 meters. Which one is bigger? Sorry guys, this copy and pasting has been so sensitive with my pen. Okay, great. So this is 63 centimeters or 6 meters. Okay, so which one is bigger? So first of all, you need to make sure that the two units are exactly the same before you even start comparing, because how can you compare when two units are different, right? So say for example, I mean, just think about this, right? When you go and do your groceries, right? For example, you're trying to buy, I don't know, dog food, for example, or if you don't have any dogs at home, like canned food, right? So if you're trying to compare two products, right, and you're comparing it in a different, I guess, unit. So say, for example, you're comparing kilograms versus grams. You can't really accurately tell which one is going to give you the most, right? Or the cheapest one, for example, or the more expensive one. So that's why I think this is really important when it comes to identifying which one is bigger. So yeah, whenever you're comparing, for example, liters is a good one too, when you're trying to buy, I don't know, like juice or something. So you need to make sure that the units are the same, right? For you to have that accuracy when you're trying to buy something, right? So if you have centimeters or meters, right? That means one of them needs to be centimeters or one of them needs to be meters, right? So if you have meters, right, I can easily convert this into centimeters because I know that for every 1 meter, this is 100 centimeters, right? So if this is 100 centimeters, that means when I cancel out my meters, right, I'm going to get centimeters. Does that make sense? So you're going to apply unit analysis here, or dimensional analysis, because you know that for every 1 meter, right, you want to get rid of your denominator, which is in meters, therefore you get to centimeters. So this is actually 600 centimeters, right? So now, because both of them are in centimeters, you can actually say that 6 meters is bigger. Great. Okay, and just so you're wondering, okay, so how do I remember that for every 1 meter, that's 100 centimeters, right? No problem. This is my mnemonic that has been, I guess, in my head since middle school. Okay. Hold on. Let me just think of the mnemonic that I used. Okay. Yeah, so for the mnemonic, it could be depending on your teacher, right? But the way they introduce this, basically, let's see, we forgot. Okay, so King Henry basically died unexpectedly. This should be capital D, just so you know. And let me try to explain why it should be capital D. So King Henry died unexpectedly drinking chocolate milk. Yeah, I don't really use the mnemonic anymore because I pretty much remember this now. But yeah, for you who are still learning this for the first time, so we have, okay, let's try to move this if we can. Okay, so this is the mnemonic that you have to remember. King Henry died unexpectedly drinking chocolate milk. I know this sounds pretty stupid, but basically this is how you're going to remember your SI units of conversion when you're looking at kilo. This is hecta. This is deca. So maybe I can write that. Okay, so this is KILO. So kilo. This is hecto rather, not hecta. And this is deca, so DECA or KA. And this is basically your unit, which is in grams. It could be meters, it could be liters, right? It's just your standard unit. So meters or liters. And then D here should be small d now because you're looking at deci. Okay, drinking okay, deca, this is deci, and this is centi, and this is milli, right? Okay, the reason why I'm trying to emphasize the capital letter, it's because whenever you're saying kilometers, right? I know sometimes they use just the smaller case, K, but typically it should be capital K and it should be small m. Does that make sense? And then if you're looking at centi, it's actually small c and you have the small m, right? So everything is lowercase. Right. So yeah, so this is basically your mnemonic, right? Again, it could vary depending on who your teacher is, but I mean, I'm just gonna use this for now. So if you have, let's say, let me just think of a number. Okay, let's try 50. Okay, so let's say I'm currently at 50 meters, right? And I wanted to convert this into centimeters, right? So how do I know what's the number that I need to remember to convert this into centimeters, right? Aside from just remembering that this is by 100. Well, if you remember this mnemonic, right, you know where to go. So because you're moving this to the right? I guess you're starting from meters, which is in unit, and you're going this way, right, in this direction. So you need to actually bypass deci first before you get into centi. Does that make sense? So it's like you before you actually go to one destination, which is centi, you actually need to bypass a door, which is deci. Does that make sense? So if you're starting at 50 meters, you need to pass through the door of deci and then you get into centi, right? So meaning you need to have two places that you need to go to. Does that make sense? So that means when you're moving this twice, as you can see, there's like two over here, two places, you would have to multiply, right? Because you're moving to the right. So anytime you're moving to the right, you're multiplying. That's the operation that you're using. And then on top of that, because you're moving twice, that means that's the number of zeros that you have after one. So that means this would be two zeros because you're moving twice, right? And you're moving to the right, therefore it's multiplication. So if you have 50 meters, therefore in centimeters, right, that would be, let's see, 5, 0, right? And you're adding just 2, 1, 2. Let's see, 1. Yeah, so it should be 5,000 centimeters. Does that make sense? So this is 5,000 centimeters. Okay, so that's how you go from 50 meters to centimeters. Okay, great. So now that you know that, maybe we can try, for example, kilometers, because I think it's a pretty popular question, right? or unit to be using, especially when your parents are driving. So if you have 50 meters, therefore you're going to move this to the left now, right? So this is one because you need to pass deca, and this is the second one because you need to pass hecto, and finally you're going to go to kilo, right? Because that's where you want to go, right? And as you can see, you're moving 3 places to the left, right? Because you're moving to the left, that means it's division, right? And because it's 3 places, therefore you need to have 3 zeros, right? 1, 2, 3. Does that make sense? Therefore, if you have 50 divided by 1000, right? Okay, so if you have 50 divided by 1000, you're going to have 5 divided by 100, so that's 1 over 20. Yeah, 1 over 20 is actually 0.05. Yeah, so in that case, you can say that 50 meters is equal to 0.05 kilometers. Does that make sense? So that's how you're going to remember this mnemonic. Okay, so that's related to that question. So, because I don't want you to, as a student, I don't want you to just remember things. Okay, for every meters, that's 100 centimeters. I want you to actually make sense of where that number is derived from. Does that make sense? So you don't have to just memorize things without even understanding where you got them. So, yeah. So as you can see, right, from meters to kilometers, right, you need to divide by 1000, and that's because of this, right? Yeah, like in math or anytime you're learning, right? I mean, just watching people over the internet, you like whatever they're doing, you need to understand them. You don't just follow them just because, what they're doing is the norm, right? So that's just my opinion. So, okay, this is 290, right? So, yeah, hopefully this makes sense. Yeah, and what they have here, 1 meter is equal to 100 centimeters is right, and they're saying 6 meters is 600 centimeters, which is right. Okay, great. Okay, so yeah, again, the question isn't here, but just by reading the solutions, I can actually tell what the question is. So let's go. So here it says the answer is the average of integers from 25 to 41 is 33. So they're looking for the average of integers starting from 25 to 41, right? And anytime you have a question like this, so say for example, instead of writing, 25, 26, 27, so on and so forth until you get to 41, right? That's probably what you're gonna do if you don't have that formula. No, don't try to do that because that's very time consuming, right? Don't try to write 25, 26 on your paper and try to count how many numbers are there or present between 25 to 41, including 25 and 41, right? So all you have to do, right, is take the mean. So just take 25 plus 41, divide that with 2, right? You get 33, and that's it, right? Simple as that. And this is right. So I know they are showing a couple of ways to get to your average, but I think the easiest one to use would be this. I mean, it takes a second to solve this, right? So 290. Okay, this is done. Okay, so the next question it says, what does a 1-to-1 ratio mean? And let's see. So they're using A and B. Yeah, it says quantities are numerically equal if the ratio is 1-to-1. And they're saying the ratio 1-to-1 means that one part of A is equal to the equivalent of one part of B, which is right. But let me give you a real life example because I like using real life examples to learn math. So, okay, so just a straightforward example. Let's say you need 5 teachers, right? Okay, so you need 5 teachers. Okay, so let's say you have 5 teachers, and for every 5 teachers, basically you have 5 students, right? Okay, so first of all, what are ratios, right? Ratios just mean it's fractions, right? So if you have 5 teachers, you can actually say this is 5 over 5 as well. It's the same thing. because ratio is just part of something, right? That's what ratios are for. So you have 5 teachers and you have 5 students, right? So that means for every 5 teachers, you need exactly 5 students, right? So in that case, when you have 5 and 5, you can actually reduce this, right, into 1, right? Because 5 divided by 5 is 1. Because remember what I said, when you have fractions and ratios are fractions, um, you can actually simplify this, right? 5 divided by 5 would give you 1, and 5 divided by 5 would give you 1. So it's a 1-to-1 ratio. So the ratio between teachers and students, it's 1-to-1. Does that make sense? For every 1 teacher, you need 1 student. That's what it means, right? Simple as that. Okay. And let's say it's not talking about 1-to-1, right? So let's say, I'm just trying to think what kind of example we can use. Let's say we're trying to bake a cake, right? Um, yeah, so some of you may not have baked a cake yet or whatever that is, but let's say you're trying to bake something, because I mean baking is math in that sense. So for example, you would have to need yeah, this is just me throwing numbers, okay? So I'm not trying to follow like the precise measurement, but let's say if you're trying to bake a cake and you probably need, let's see, 3 cups of flour. This is probably a lot. Okay, 3 cups of flour, and basically this is, okay, because I wanted this to be a common factor, right? I'm just gonna say 6 cups of, I don't know, milk, for example. Okay, so you have 3 cups of flour and you need 6 cups of milk, right? So in that sense, if you're using 3 cups of flour and that's 6 cups of milk, you can actually reduce this into terms, right? So 3 divided by 3, this would give you 1, and then you have 6 divided by 3, which would give you 2, right? So when you're trying to bake a huge cake, you would have to use 3 cups of flour for every 6 cups of milk, right? But when you're trying to bake a smaller cake, right, you can actually manipulate, or you can change up your numbers or measurements to a smaller quantity, but you need to keep that ratio consistent. Otherwise, your cake is just going to fall off, right? Or not, I guess, bake properly, or you wouldn't really have a good result at the end, right? So that's why you need to keep the ratio between your flour and your milk the same. So in that case, if you're using 3 cups of flour for every six cups of milk, and when you're trying to bake a smaller cake, let's say you need 1 cup of flour, right? You would just need 2 cups of milk. Does that make sense? Yeah, so that's basically the whole point of using ratios. Okay, so how do you find the volume of a 3D trapezoid? Okay, so instead of saying 3D trapezoid, I would reword this as a trapezoidal prism, because if you're looking at a trapezoidal prism, it would look something like this. Okay, I like this figure better because it actually shows you the bases, which is the trapezoid, right? Can you guys see this? So it's a prism because it's 3D, right? And this is a trapezoid. That's your base, right? Yeah, it shows it better as opposed to this one. That's why I like this figure better. Okay, so I know this is a different example, but I just wanted to use this figure, right? And it says what is, or actually, how do you find the volume of a 3D trapezoid? So how do you find a volume of this, right? So because they're giving us numbers, maybe we can just use that as an example. So yeah, to find a volume of a trapezoid, right, you need to multiply the area of your base, that means the area of your trapezoid, times the height, right, of your prism. So that's the formula for the trapezoidal prism. So the volume of a trapezoidal prism, yeah, let's not use 3D trapezoid. So trapezoidal prism, so that's the volume, and then basically you're taking the area of your base, which is the trapezoid or the face, and then you're multiplying this to the height of your prism, right? And the only reason why I'm trying to emphasize that this is the height of the prism, because your trapezoid does have a height as well, right? Which is used to look for the area of the base. So when you go back to this, Yeah, so when you go back to this, if you're looking at this trapezoid over here, this trapezoid itself, it still has a height, which is 8, right? But if you're looking at the prism, the height of the prism, right, when you kind of flip this up, right, you would get 10 as the height of the prism, right? So that those are two different heights. Great. So once we have that, right, let's go and find the area of the base first, right? So the area of your base, right? So what's the area of a trapezoid, right? Or a 2D trapezoid? That would be your first leg, right? Plus your leg 2 or A plus B depending on your teacher. Again, there's going to be variations in this formula, but basically you're taking the leg of your other trapezoid, or let's keep this as base 1 and base 2. And this is divided by 2 times the height of your trapezoid. Okay, so going back to the figure, actually, let me see if I can squeeze. Okay, can you guys see this? Yeah, I would have to make this smaller. Okay, great. So hopefully you guys can see this. But basically, if you're looking at the base, right, you know that this is 6 over here. This is 6 over here, therefore this has to be 6, right? So one of the bases of the trapezoid would have 6 feet, and then the other one would be 12, right? So base 1 would be 6 or 12, doesn't really matter. And then the other base would be 12 or 6, right? So I'm taking 6 plus 12 divided by 2. And then the height of the trapezoid, as I mentioned, it's actually 8, right? So you're taking this times 8. Okay, so we know that this is 6 plus 12 divided by 2 times 8. That's going to be 72, right? And let's see what units they're using. They're saying it's feet, right? Because we know it's units of area, therefore this is square feet, right? So it's 72 square feet, but we're not yet done because we need to find the height of the prism and multiply that to get the volume of the trapezoidal prism. So the height of your prism is actually 10 feet, right? So this 10 is basically your height. So you're going to take 72. So this is 72 feet or square feet times 10 feet, right? And it makes sense because if you have square feet times feet, that would give you cubic feet, right? So this is 720 cubic feet, right? So therefore, you know that the volume of your trapezoidal prism is going to be 720 cubic feet, right? And in order for you to find the volume of your trapezoidal prism, because anytime it's a prism, it's 3D, right? You understand that it's 3D, therefore you're going to find the area of your base or the area of your trapezoid times the height of your prism. Okay, so I guess we can wrap this class up. Let's see. Okay, yeah. So we can just end off this class from this point on. I just wanted to say that this session and all of my sessions will be recorded, so you don't have to panic in terms of trying to write things down because they will be available at your convenience after this class. Okay, great. So we'll be having Q&A classes for math. So starting today, right? And if you're interested to check out my daily schedule, because I do host live classes and their daily classes, and the best part is their free classes. So you can check out my schedule here because not only do I teach this Q&A class, I do teach other classes as well. So this is oneclass.com/livestream. So this is where you can find my daily schedule. So yeah, go to this website. You'll find my daily schedule for my classes that are live and also other talented educators who have their own classes as well. So yeah, these are for math and chemistry, and I hope today's class you found it to be productive and insightful. Again, if you do have any friends, just bring them to this class. Yeah, so thank you so much guys for tuning in, and I'll see you on my next class. Bye guys.